Okay, 2.2.9. I looked up the answer in the back of the book, and I think it's wrong because I checked with Wolfram Alpha, and it agrees with me. So let's get into it. So theta is going to be 180 degrees because we're looking at the angle for this one. That's 180 degrees because it's a negative number. We're going to go for the x value, theta over n. Theta is just going to be that 180 degrees, and then n is going to be this value here. And we end up with cosine negative 60 plus I sine negative 60. So then we go for the s value, which is 360 over n, which is just going to be 360 divided by 3, which is 120. So there you go. And then the magnitude of this. So let's just find the magnitude of z, which is just going to be 1. Magnitude of 1 is 1. And then we take the third root of that, which is just going to be 1. And keep going. So here's my little formula that I like with the x and the s values. And so the first, when k is 0, we don't need to worry about the magnitude of the nth root of z because that's just 1. We also don't need to worry about s to the 0 power because k is 0, so s to the 0 is 1. We just need to worry about that x value. So the x value is going to be 1/2 minus root 3 over 2i, and that does not agree with the back of the book. However, it does agree with Wolfram Alpha, so I would trust this one right here. And I did a little bit of special triangle stuff, and it works. Keep going. This time the s to the first power, we need to do that. And then remember when we multiply two complex numbers that the angles add, so we're just adding 60 plus the 120, which will give us 60. So just do the special triangle stuff, and you'll see that's 1/2 I root 3 over 2. And then we just repeat that a third time, but this time we figure out that, oh, we're actually at 180 because 240 minus 60 is 180. So we end up with -1 on this one. And yeah, there we go.